we have to start the microscopes lesson. Small lesson. How many pages in the tute? How many pages in the tute?
8.
8 pages. So we are going to discuss those 8 pages and going to complete the microscopes lesson. Clear? Right. If you take microscopes, microscopes are magnifying instruments. Any magnifying instrument can be called by the name microscope. So microscopes are nothing special. They are magnifying instruments, right? So some knowledge we have already regarding the microscopes. In this lesson, little more detailedly, we are going to speak about the microscopes. First of all, in the microscopes, in the tube you are given, take the tube in the you are given. Okay. In the tube you are given, you are given the definition for microscope. What is the definition given for the microscope? What is the definition given for the microscope? Tell me.
Devices that perform magnification of a specimen are called microscopes.
Devices that perform magnification of a specimen is called by the name microscopes. Microscopes, thereafter I have given you a heading. Classification of microscopes. There are 2 types of microscopes there. According to the type of rays they are using. One we call light microscope, other one we call electron microscope. What are the 2 types of microscopes?
Light microscope and
Light microscope and electron microscope. Light microscope can be divided to 2. One we call simple microscope, other one we call compound microscope. What are the 2 types of light microscopes?
Simple microscope, compound microscope.
Compound microscope. Electron microscopes can be divided into 2. One we call transmission electron microscope. Second we call scanning electron microscope. What are the 2 types of electron microscopes?
Transmission electron microscope.
Transmission electron microscope and scanning electron microscope. So it is that classification you have to place in your tute under the heading classification of, what is it? Microscopes. Okay. So you are first dividing microscopes into 2. Light microscope, electron microscope. Light microscope dividing again to 2. Simple microscope, compound microscope. Electron microscope you are dividing into 2. Transmission electron microscope, shortly we call it TEM. And the second one, scanning electron microscope, that is SEM. Complete the classification. Completed? Have you completed it?
Yes, sir.
Yes, sir.
So thereafter, you are given small ideas. One, it is you are pointed the person who invented the first microscope. The first microscope was invented by, take a look at your tube, who invented the first microscope?
Anton van Leeuwenhoek.
Anton van Leeuwenhoek. Anton van Leeuwenhoek invented the first microscope. Actually, after inventing microscope, Anton van Leeuwenhoek observed pond water, and in the pond water he was able to notice bacteria, euglena, like microorganisms. Thereafter only the world got to know there are microorganisms in the world. Understood?
Yes,
Yes.
sir.
Due to this reason, Anton van Leeuwenhoek is also called in the name father of microbiology. He is the father of microbiology. Microbiological world was opened by
Anton van Leeuwenhoek.
Anton van Leeuwenhoek. Clear?
Yes, sir.
Yes, sir.
After Anton van Leeuwenhoek invented the microscope idea was widespread. Then Robert Hooke, he made a microscope for him. Using that microscope only, Robert Hooke observed the cells. Okay. And the concept of cells was explored to the people by the use of the microscope. So if microscope was not invented in this world, still we will not be aware of
Cells.
microorganisms are there. Still we will not be aware of cells present in the organism. But anyway, those microscopes used by Anton van Leeuwenhoek, used by Robert Hooke, both of them are compound microscopes. Compound microscopes we were using for a longer time. Using compound microscope in the biological world, cells, nucleus, chloroplast, bacterial cell like structures were noticed. But you are pointing now in a cell, what do you say, endoplasmic reticulum, Golgi apparatus, okay, ribosomes, cytoskeleton. These structures were not be able to notice using these compound microscopes. Actually, they say it is after the invention of electron microscopes. After the invention of the electron microscopes, the world was able to differentiate or separate prokaryotic organisms and eukaryotic organisms. If electron microscopes are not there, we are not able to detailedly observe inside a cell. So detailed idea about a cell will not come to us if electron microscopes are absent. Same way, virus like very small particles, when you go to the other lessons you will be studying, there are now according to our knowledge, your knowledge, What is the smallest living component? Bacteria. Smaller, okay, after bacteria, the smallest part is virus, correct? Yes or no?
Yes, sir.
Bacteria is the smallest organism, my children. Anything below bacteria is not called organism. Virus is not considered as an organism. Okay? But same time, there are particles. You will study a kind of microscopic units called prions. So prions are microscopic structures that are causing infectious diseases. Viroids are there, microscopic structures that cause infectious diseases. A kind of prokaryotic cells are there called molecules, not visible to compound microscope. All these ones were explored to this world only by electron microscope. Understood?
Yes, sir.
Right? So, accordingly, in in complete cell biology, in exploring the cell, its components, microscopes have played a significant role. That's what you want to understand first. It is what it has been given to you in the page number 1. Please go through the page number 1 and tell me whether it is clear.
Clear, sir.
Is it clear?
Yes, sir.
Good.
Clear, sir.
So remember, every microscope is what kind of device? What kind of device? Microscope is a magnifying device, correct?
Yes, sir.
Yes, sir.
Right. Every microscope has a property called resolving power. What is the property?
Resolving.
Resolving power. One important property of every microscope is resolving power. Second important property of microscope is, what is it?
Magnification.
Magnification. Any microscope you buy, you have to look for these two. One, you have to look for the, what is it? Resolving power. Other one, you have to look for the
Magnification.
magnification. Okay. In these two, first of all, let us discuss about the resolving power. Right. I am asking you a simple question. I am drawing a dot here. Okay. Can you see this dot?
Yes, sir.
Yes. Do you know why can you see this dot? Because its size is more than how much?
0.1
0.1
millimeter.
0.1 millimeter. It is the resolving power of our
I.
eye. That would have been heard about, that human eye has a resolving power 0.1 millimeter. Have you heard about it?
Yes, sir.
Yes. Once you go on diminishing its size, right? Now still you can see, correct?
Yes, sir.
Yes.
Yes, sir.
So there will be one stage you can't see that. Okay. Why it is becoming that you can't see that? Why it is becoming that you can't see that? The reason, it is becoming smaller than your resolving power. So what is our resolving power?
0.1.
0.1 millimeter. What is the meaning of it? Okay. Any object having a diameter 0.1 millimeter or greater is visible to human naked eye. Understood? Understood.
Yes, sir.
Yes. Remember, 0.1 millimeter equal to 0.1 millimeter equal to 100 micrometers. You know micro sign, correct?
Yes, sir.
Yes. So how many micrometer 1 millimeter? Sorry, how many micrometer 1 millimeter?
10 to the power minus 6.
Simple. 1 millimeter equal to 1000 micrometer. Understood? 1 millimeter equals to how many micrometer?
1000 micro.
1000 micrometer. So 0.1 millimeter equal to
100 micrometer.
100 micrometer. So what is in micrometer? If you tell, what is the smallest size you can notice using human naked eye?
100 micrometer.
100 micrometer. If it is 99 micrometer,
Not visible. Can't be
you
observed.
can't see that. Are you clear?
Yes, sir.
Right.
Yes, sir.
Right. Now, if you take a compound microscope, look at your tube. What is the resolving power given to a compound microscope?
0.2 micrometer.
0.2 micrometer, correct?
Yes, sir.
Yes. So that means, what is the meaning? Any object, okay, having a diameter, okay, equal or greater than 0.2 micrometer is visible under which microscope?
Compound microscope.
Right. That means, now for a simple example, keep this one. Keep this one. If you take an plant cell, a plant cell has a size of 50 micrometer. How much?
50 micrometer.
50 micrometer. Okay. In this case, can you see it by human naked eye?
No.
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 So it is not visible visible to human naked eye, correct? But
Yes, sir.
visible under
Compound microscope.
Compound microscope, because compound microscope you can observe up to if it is more than
0.2
0.2 micrometer. If it is more than 0.2 micrometer, any size is visible under compound microscope. Okay. Next one. If you take animal cell has a size approximately 30 micrometer. Remember, it is smaller than plant cell. What about animal cell?
Can't be observed under
Okay,
human
so
eye.
it is also not visible to human naked eye, correct? But visible to
Compound
visible
microscope.
under what is it? Compound
Microscope.
microscope. Clear?
Yes, sir.
Right.
Yes, sir.
The average virus also can differ in size. Average virus size is 0.1 micrometer. So, is it visible under human naked eye?
No.
Oh, okay, that is agreeable, correct? Not visible under, visible to human naked eye. What about compound microscope?
Not visible.
Not visible. Am I right?
Yes, sir.
Not visible under, what is it? Compound microscope. So you have to understand one thing. It is the resolving power that decides whether you can use a microscope to observe a thing or not. Understood?
Yes.
Yes, sir.
Okay, whether you can use it or not is decided by, now I told you, okay, there are particles like prions, like things, smaller than virus there. So if one person say, I will use a compound microscope and observe the prions, mean it's a joke. So whether it is visible under a microscope or not is decided by which power?
Resolution.
The resolution power. Understood?
Yes,
Right.
sir.
If you take electron microscope, what is the transmission electron microscope? Okay, transmission electron microscope. What is the value given?
0.2 nanometer.
0.2 nanometer. 0.2, what is it? Nanometer. It is actually 0.0002 micrometer. Understood?
Yes, sir.
So now tell me, can you notice virus? Virus size is 0.1 nanometer. Sorry, 0.1 micrometer. 0.1 micrometer equal to 100 nanometer. So using a transmission electron microscope, can you observe virus?
Yes.
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 Okay, there are units called prions. Prions will be having about, okay, 10 nanometer size. Can prions be observed under TEM?
Yes, sir.
Yes. So are you clear
Yes, sir. Yes,
Are
sir.
you clear? The idea
Yes, sir.
behind resolving power.
Clear, sir.
Clear.
Yes, sir.
So please go through your note and tell me whether the note is clear. If the note is clear, I can move to the next. First name? Aslam. Oh. Are you clear?
Yes, sir.
Right.
Yes, sir.
Now you are given a question. What is the question you are given? Are you given a question?
Yes, sir.
Yes. What is the question you are given?
How many times resolution power of compound microscope is higher than human eye?
Right. So actually, one thing you have to understand, if the value is small, you can see smaller things, correct? Right?
Yes, sir.
Yes.
And that is considered as a higher resolution power. Understood?
Yes, sir.
Small number they are mean what kind of resolution power?
Higher resolution.
Higher resolution power. Don't think small number means small resolution. Because of high resolution, it is helping us to see small things. Understood?
Yes, sir.
So if you compare the resolution powers, okay, compared to human eye, okay, compound microscope has a greater resolution power. Compared to compound microscope, SEM has a greater resolution power. Compared to SEM, TEM has a greater resolution power. If you take them in values, value wise, TEM is the smallest. Understood? Am I right? Are you clear? Are you clear?
Clear, sir.
Clear.
Clear. Now in the question, we are asking, compared to human eye, how many times resolution power of compound microscope is greater? In this case, you have to divide resolution power of human eye by, in this kind of question comes, you have to divide the resolution power of human eye by resolution power of whom?
Compound microscope.
Compound microscope. So if you take resolution power of human eye, how many micrometer?
100 micrometers.
100 micrometer, correct?
Yes, sir.
If you consider a compound microscope, how many micrometer?
0.2 micrometer.
0.2 micrometer. If you divide it, it is 1000 divided by 2. How much is coming?
500.
500. What is the meaning? Resolution power of, okay, compound microscope is 500 times greater than, what is it?
Human eye.
Human eye. Are you clear?
Clear, sir.
Sir.
So remember, the human eye, it has the lower value. It is the one we place as the numerator. Then only 500 will come. If you do it other way, will 500 come?
No.
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 Okay. Complete it. Complete it.
Done, sir.
Have you completed it?
Yes,
Yes,
sir.
sir.
Right. So below I'm asking, what is the meaning of the calculated value? That is the answer. Resolution power of compound microscope is 500 times greater than the, what is it?
Human eye.
Human.
Human eye. Okay.
Okay, sir.
Are you clear?
Clear.
Clear.
Yes, sir.
Now resolution power is over. We are coming to the heading called, what is it?
Magnification.
Magnification. First of all, I will tell you the basics behind the magnification. magnification means, okay. Hello. Right. Magnification. Okay. The basic idea behind magnification is it is a ratio we obtain size of the image divided by size of the object. Understood? How do you get the magnification?
Size of the image divided by size.
Size of the image divided by, what is it?
Size of object.
Size of the object. Okay. If the value is coming to, say, what is the meaning? Image is 2 times larger than the object. Understood? If
Yes.
this ratio is coming to, what is the meaning?
Image is 2 times larger than the object.
Image is 2 times larger than the object. Understood? If the image, if it is coming 100, what is the meaning?
Image is 100 times larger than the object.
Image is 100 times, okay, larger than the object. Remember, in physics, when you are studying in physics, okay, you will be getting other way values also. Now something like how much? 0.5. That is, image is 2 times less than, smaller than the object. Understood? But that kind of things will not come here. Reason? We are speaking about microscope. Microscope does only magnification. Image will be larger. Image has no chance of becoming smaller. Correct?
Yes.
Image will be larger. Image has no chance of becoming, what is it?
Smaller.
Smaller. So, are you clear regarding the magnification?
Yes, sir.
Right.
Yes.
So, using this one, I have asked a question. Size of an image. Okay. Size of an image is how many millimeter?
0.2 millimeter.
No, it is a wrong thing. Size of an object is, put a small correction there. Humaira, எனக்கு Okay. Okay.
Okay, sir.
Okay, sir.
Right. So in the Humaira didn't get the printout of the tute. Is it so?
No, sir, I got the printout.
என்னமா குழப்பம் எனக்கு உண்மையே விளங்கல. Right. So in the page number 3, my first question it is, what is the meaning of the mentioned value? You are finding how much you found? How much you found? According to the question, how much you found, my children? Hello? Hello? Everyone? 100. So you are finding the value 100. Have you all got 100 as the value
Yes,
for the
sir.
magnification? Yes. Now in the next page, I am asking, what is the meaning of that 100? What can you say?
Magnification ratio.
Magnification is 100 times. Okay, magnification is 100. What is the meaning of that?
The object is magnified 100 times.
Yeah. Otherwise, tell this way. That is easy. Image is 100 times larger than
Actual
Object.
size of object.
the object. No need to drag. Simply say, what is meant by that 100?
Image is 100 times larger than the object.
Object. Simple words. Simple words, simple idea. Clear?
Clear, sir.
Yes,
All
sir.
right. Have you completed the answering?
Yes, sir.
Yes. So we are coming to another point to you. What is the point given to you? What is the point given to you? Magnification is connected to, what is it?
Resolving.
Or related to resolving power. Okay. If resolution power is high only, if the resolution power is high only,
Higher magnification is
higher
possible.
magnification is possible. I will try to little explain this point with this idea. Don't know whether it will be a good one or a bad one. I'm just searching for a heading called, what is it? Rose flower in the internet. I'm just searching for the word rose flower. Okay. If you take these photos coming in the internet, when you click it, in this place, they will mark the resolution. Can you see the resolution? Can you see the resolution here?
Yes, sir.
Yeah, that is the resolution. Now, when you click here, it has a higher resolution, correct?
Yeah.
2000 bigger resolution. When you search and go, some will be in a poor resolution. Rose, no, most of them are giving higher resolution. Okay. Some of them will be having a lower, what is it? This is a lower resolution. How much is the resolution? 640 into 480. When you magnify it, now if you come to this level, you will see some smudgeness in the picture. Can you see?
Yes, sir.
That means that clarity, when you magnify, what happened to the clarity?
Reduces.
Reduces.
Reduce it.
Because its resolution is low. Understood?
Yes.
Yes.
Because its resolution is low, when you magnify it, what is happening to its clarity? Now this one has a higher magnification. Okay. Even in this level, does its clarity decreases?
No.
No.
No. Can you understand the difference?
Yes, sir.
Yes,
One
sir.
side we can say resolution is the clarity. Understood?
Yeah.
Resolution is the clarity. So higher resolution will give higher clarity even under higher magnification. Understood?
Yes, sir.
So if the resolution is low, if you magnify with low resolution, what will happen?
Lower clarity.
It will start to blur. It will start to smudge. Understood? See the resolutions level. Even the small damage marks in the flower can be noticed. Correct? Small streaks can be noted. Dots can be noticed. Correct?
Yes, sir.
That much higher clarity in this magnification level. Right. And thereafter, I'm asking you a question. The question it is, maximum magnification of a compound microscope is how many times? How many times? Tell me. How many times? Huh? Tell me. You are given
1,000 times.
1,000 times. Okay. Now, this is my compound microscope. Okay. In this place, it is written its magnification. This compound microscope's maximum magnification is how much? How much?
400.
400. This can maximum magnify how much?
400.
400. But there are compound microscopes that can magnify up to 1,000. 1,000 is the maximum limit. Thereafter, if you try, okay, you can magnify, but clarity will not be there. Understood? If you go
Yes.
for 2,000, 3,000, can't we do? Mean can do. But will you notice it clearly? Mean what is it?
No.
No. But maximum magnification of an electron microscope is how many times? They say 500,000 times. That depends on the electron microscope. Okay. What is the reason? What is the reason? Reason? Simple reason. Compound microscope have a lower resolution power and electron microscope has a greater resolution power. Clear?
Clear,
Who
sir.
has a greater resolution power?
Electron microscope.
Electron microscope. And compound microscope comparatively has a lower power. That's the reason. Complete it. Complete the answering.
Done, sir.
Okay. So there's an important point to you. You can further improve that point. Okay. I thought of telling that one in the last. We'll see. Okay. We'll speak about in the last. Okay. Now we are going to speak about light microscope. You know, light microscope mean what is the source energy? Energy light. Okay. You know, there are two types of light microscopes. What are the two types of light microscopes?
Simple light
Simple microscope and
Simple
compound
microscope and
compound microscope.
Compound light microscope.
compound microscope. Okay. What are the uses of simple microscope you are given?
To observe the parts of a flower.
To observe the mouth.
Good things. Reading in tiny letters, correct? Tiny letters, you can what is it? Tiny letters, you can see. Parts of a flower, you can see. Mouth parts of an insect, you can see. Good things we can do. But microorganisms, can you notice using the hand lens?
No.
No.
So to observe microorganisms, the choice is using a which microscope? Compound microscope.
Compound.
Minimum you have to use a compound microscope. Clear?
Yes, sir.
Right. So I am going to introduce you the parts of compound microscope. The parts of what is it?
Compound microscope.
Compound microscope. This is not compound microscope. Okay. It is to keep the compound microscope. Okay. This is the upside. It's the upside. This is my compound microscope. Right. If you take a compound microscope, this is not the first time you see a compound microscope, correct?
Yes, sir.
Even in your grade 7 or something, you studied. But here, little more detailing, that's all. Okay, remember, this particular lesson is a combination of the practical guidebook as well the theory book. That means your resource book. So All the details will not be there in the resource book. Practical guidebook also you have to see to get to understand my full note. Understood?
Yes, sir.
Yes. So if you take the tute, the parts of this one is little by little introduced. One by one introduced. First thing, to this height I need something now. Right. Okay. So what are the parts? Read one by one the parts. Read one by one the parts. Tell me.
IP.
IPs. Here I have the, what is it?
IPs.
IPs. Generally, they don't give a container for IPs. Only this kind of a bag is there. Okay. We used to place it in this one. That is the location for the IPs. Second one. Second one.
Objective lens.
Objective lens. I have 3 objective lens. Okay. I have 3 objective lens. This is one objective lens. See the magnification written on it. How much is the magnification written? Can you see?
4.
4. Correct? 4 written. So 4. This is, it's a hollow part here. There's a small lens there. It is the low power objective. This is called nose piece. I can fix it like this. Nose piece. Right? This one, the second. How much written here?
10.
10.
10. This is the middle power objective. Which power?
Middle power.
Middle power, medium power, middle power, or otherwise we can call it, what is it?
Medium power.
Medium power objective. Then this one, it is the high power objective. Right? So these 3 objectives are there. High power objective. This is low power objective, and this is
Medium power.
medium power objective. Actually, at a time, only one objective will function. At a time, only one objective will function. Now it is straight to this aperture. It is straight to the, this is the lens straight to the aperture. It is the low power objective. This is, what's it? middle power. Now it's going to work in middle power. If you bring the high power, now it is going to work under, what is it?
Power.
High power.
High power objective. Clear?
Yes, sir.
So 3 objectives are there. Some, now the modern ones have, some of them have 4 also in it. And normally 3. Middle power, low power, and what's it?
High power.
High power.
High power.
Right. And this is fixed to this piece called nose piece. Nose piece. Nose, okay. I think it's looking like, this one is looking like the holes of the nose, isn't it? Someone's nose like down. So due to that reason, I think it is called nose piece. So it is rotational. It is rotational. You can rotate it. Okay. Rotational nose piece is there. Okay. Next one. Next part.
Mirror.
Mirror. Mirror.
Mirror.
Mirror. So here in the bottom, there is a mirror. If you take this mirror, it has 2 sides. This side is a concave mirror. What kind of mirror?
Concave mirror.
Concave.
That's why you can see it is some creating a different type of imaging, correct?
Yes,
Yes.
sir.
Yes. Other side is a plain mirror, normal mirror. That is giving a normal appearance, correct?
Yes.
Yes, sir.
Okay, so there are 2 mirrors. One side is a concave mirror, other side is a plain mirror. Depending on the place where the light is coming, you can decide whether you are going to use the plain mirror or you are going to use the concave mirror. You can decide. Okay, next one.
Condenser lens.
Condenser lens. Here you can see the condenser lens is fixed to this place. Can you see?
Yes,
Yes.
sir.
Yes.
Yes, sir.
It is a convex lens. What kind of lens?
Convex.
Convex.
Convex lens. The only thing it is, you cannot, it is not involving in the image formation, because on this only the slide will be there. The slide will be situated on this, correct?
Yes.
Light coming through this is hereafter, after passing this lens only going to touch the specimen. Specimen mean that kutti thing you see inside the slide is called by the name, what is it?
Specimen.
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 So if you want to see the specimen, okay, hereafter light is coming through, then only it is moving through the specimen. After moving through the specimen only, it can do the magnification. In that case, can this lens do the magnification?
No.
No.
No. In some microscopes, this condenser lens will be here fixed and we can remove it. But in mine, it is fixed to the stage. Can't remove. Understood?
Yes, sir.
Okay, depending on the microscopes, it will differ. Next one,
Diaphragm.
diaphragm. Diaphragm you can see here. Can you see a dish-like thing? A disc-like thing? Can you see?
Yes, sir.
Can you notice there are holes in it?
Yes, sir.
Yes.
Yes,
Yes.
sir.
Okay, I'll just put on this light. Okay. Here, now this hole is straight to the condenser lens. If you bring this hole is big now.
Yes, sir.
Then more light can enter. If the hole is big, what is the benefit?
More light can enter.
More light can enter. If you turn it, then you are reducing the light that enters. You might ask, sir, why should we decrease the light? My children, the light you see through this should be comfortable to your eye. Understood?
Yeah, sir.
Yes.
Too much of light is damaging, and too much of light is harmful to your eye. Same time, if it is dim also, image will not be clear, correct?
Yeah, sir.
So we can't find, okay, give a dim image. No, that we don't agree. Same time, image is too much bright mean, then can't see it for a longer time, very difficult. So we are given a choice. You can adjust the amount of light that enters according to the clarity, according to your comfortable level and your clarity. Clear?
Clear.
Yes, sir.
Yes, sir.
Are you clear? Right? What is the next one?
Stage.
Stage.
Stage. Here the stage. On the stage only we keep the slide. On the stage only we keep the slide. Okay. To fix the slide in a place, we are using this stage clips. Now, if you go and buy microscopes in the market, very sophisticated, and now there will be several different clips there. You can fix and you can move this. Understood? Now, if you fix a slide here, how to move it? Move it with your finger, correct? Moving like this. But nowadays, standard methods are there. Fixing, and there will be screws you can move forward and backward, and correctly how to bring the specimen to this aperture. Then only you can see it clearly. Okay, next one.
Stage clips. Stage clips.
Stage clips. I told you about stage clips. Next one.
Coarse adjustment knob and fine adjustment
Right.
knob.
Here there are two adjustments. There. This large wheel is called
Coarse adjustment knob.
coarse adjustment. This small wheel is called
Fine
Fine
adjustment.
adjustment.
fine adjustment. Some microscope will have coarse adjustment and fine adjustment together in one place. Modern ones are coming like that. Understood? Modern ones are coming like that. This is not a modern one. This I bought in 2008 or 9. 8, I think. So how many years? How many years? 15 years, correct?
Yeah,
The
sir.
15 years old one. But now there are more ones coming. Nowadays, now here there's a mirror now. Okay. Without having a mirror here there will be a light source, the bulb wire coming. Okay. Here there will be a knob. You can increase and decrease the brightness of the bulb. Understood?
Yes, sir.
Okay. That kind of facilities are there now. Okay. But remember, in schools, the microscopes available will be worse than this. Okay. Still using that old one. Okay. Now, course adjustment. Course adjustment will help you to move the body tube. You can move it. You can see. Is it moving?
Yeah, sir.
Yes.
Yes, it's moving. When you are moving the course adjustment, you can see it is quickly moving, correct?
Yes, sir.
Right. Fine adjustment, if you turn, it will move, but it is not visible to you that much. What is it? A minute movement will be there. There will be a minute movement there to move. Okay. Fine adjustment. So actually, in this place only the slide will be there, correct?
Yes.
Am I right?
Yes, sir.
This is the lens, correct?
Yes,
Yes,
sir.
sir.
Yes. By moving this, what are you doing is, you are changing the distance between the specimen and the lens. Clear?
Yeah, sir.
Okay, to get a clear image, what is the feature you are changing? What is the feature you are changing?
Distance.
The
Distance.
distance between whom and whom?
Specimen and
Lens and object.
The specimen and the
Lens.
objective lens. Okay, until you get a clarity, you have to do it. The most recommended one it is, you have to move the lens maximum downwards. Now see, I am moving. Now it is no more moving, right? Can you see? It's no more moving.
Yes, sir.
Yes.
Okay, that means it is at the minimum distance between whom and whom?
Lens and specimen.
And the lens.
The lens and the specimen. Now if you see, some it might not be clear. Then the only choice to make it clear is moving it in what direction? Moving it in what direction?
Upward direction.
Upward direction. Okay, it is not moving down and up. That is not recommended. Fully move it down, keep it like this. Okay, then see, no clear mean little by little move it. What is it?
Upward.
Upward. Another thing is that if you are a right hander, you have to use which hand to move it? Your left hand to move it. If you are a right hander, why so? Then only you will be moving slowly, correct?
Yes, sir.
When you are doing with your strong hand, normally what comes is you will make a quick move. If you are using your weaker hand, how to move?
Slowly.
Slowly. So many things are there to understand how to use a microscope. Okay, tell me the next.
Body tube.
Body tube. This is the body tube. This part is called by the name. What is it?
Body tube.
Body tube. Here there will be lens. Here there will be
Eyepiece.
eyepiece, correct? Here there will be lens, here there will be eyepiece. This distance between eyepiece and lens, will it change? This distance, will it change?
No.
No, it is a fixed distance. When you are moving, the whole thing is moving up and down. Understood?
Yes, sir.
Okay, so in some nowadays, the modern ones, some of them have this is not moving. Which is not moving?
Eyepiece.
Body tube is not moving. Stage will be moving up and down. Clear?
Yes, sir.
When the stage moves, so body tube moves, we don't have any problem. If the distance between the lens and the eyepiece changes, that is enough. Clear?
Yes, sir.
Clear, sir.
Right? Right. So next one. Oh, arm. This is the arm. In that only we give the support. If you are carrying it, you have to carry it like this. arm, and this is called base. You are keeping strongly. You are keeping the place you are keeping should be a steady place. இப்படி ஆடுற மேசையா இருந்தா வைக்க கூடாது. Understood?
Yeah, sir.
Yes.
Right. Have I introduced all the parts or anything remaining?
Stage height adjustment.
Stage height adjustment. Okay. அது இதுல இல்லைம்மா, சிலதுகள்ல இருக்கும். There is a unit called, what is it? Stage height adjustment. Okay. You can adjust the height of the stage. You can little make move upward or what is it?
Down.
Downward. Anything else?
No, sir.
No. So we are going to discuss little now, almost a brief idea I gave you regarding this. Okay. Some detailed ideas we are going to tell here. Okay. That is going to be our lesson now. Right. Here, one by one, some of the ideas I have given you. Eyepiece. Eyepiece is what kind of lens?
Convex lens.
Convex lens. It is fixed to the which part?
Optical tube.
Optical tube. Optical tube mean this upper part is called optical tube. This portion is called, what is it? Body tube. We can even remove this. Understood? We can remove this. This is the, what is it?
Optical tube.
Optical tube. So eyepiece is fixed to the
Optical tube.
optical tube. Okay. In the eyepiece, look at this eyepiece. What is the number marked?
10.
10x. That means it can do a magnification of how much?
10 times.
10 times. Okay. Different eyepieces are there. Some eyepiece would be written 15x. Some eyepiece would be written 20x. Okay. Different eyepieces are there. That's why I have mentioned like this. What are the possible magnifications for eyepiece?
10, 15, 20, and 25.
Right. So, what is the function of the eyepiece? Read it.
It performs the magnification of intermediate image created by the objective lens for the second time.
Right. Actually, the first image for the, now here is the object, here is the objective. This is the one going to make the first image. That image will be coming in this region. Understood?
Yes.
This is the place where the object or specimen is there. Light is first going inside whom?
Specimen.
No.
Objective
After
lens.
passing the specimen, it is going inside whom? Objective lens. So it is the objective lens making the image. Who is making the image?
Objective lens.
Objective lens. That image will be found here inside. that image is used by whom? Eyepiece as its objective. So object, specimen here, objective lens here, image here. That is one set of work. Specimen, objective lens, image. This specimen's image is coming here by whom?
Objective lens.
Right. That doesn't have any connection here. For eyepiece, which one is the object? Which one is the object for the eyepiece? Here there is an image, no? Correct?
Yes.
Yes, sir.
That image is working as the object for the
Eyepiece.
eyepiece, and it will form another image using that image as the object. Clear?
Yes, sir.
Yes.
Right. So the first image coming, is it the final image?
No.
No.
No. First image is used by the eyepiece and the eyepiece develops another image. That is the final image. Okay. So first image is coming here. That image is used by this to make another image. That is the final image. In that case, the first image, can't we call it an intermediate image? The first image, can't we call it an intermediate image?
Can, sir.
Can. Right. So are you clear regarding the eyepiece?
Yes, sir.
Yes.
Sir.
Next we speak about the objective lenses. How many objective lenses are there?
3.
3.
3. What are the 3 types?
Low power, medium
Low-
power.
Low power objective, middle power objective and
High power objective.
high power objective. For a low power objective, what are the possible magnifications?
4.
Into 4, into 5, into 10 can come. For middle power objective,
Into 10, into 15.
into 10, into 15. And high power objective,
Into 40, into 100.
into 40, into 100. My high power objective has how much?
40.
40. That is why 40 here, 10 here, 40 into 10, how much?
400.
400. That is the value. Understood?
Yes, sir.
40 into 10, 400. That's how that 400 comes. Okay. So, you know, it is the one making the first image of the specimen. Am I right?
Yes,
sir.
Yes. Thereafter, regarding home,
mirror.
mirror. Mirror, if you consider, what is the first point written under the mirror?
Placed at the bottom below the
Placed
stage
at
in the
the
same
bottom, below the stage, below the stage.
in the same axis of the body tube.
Okay, body tube. Now, if you send a combi through this, it will first break and come through this. Then it will go through this, and finally will touch the center of the mirror. Understood? If you send a combi, that combi will travel through this and will break and come through this. That combi then will go through this. Breaking that one, it will come here. That means all of them are in a single axis. Understood?
Yes.
Yes. Right.
Yes, sir.
Next point to you.
One side is a concave mirror and next side is a plane mirror.
Okay, I told you already. Now, this kind of an image is coming mean what type of mirror it is?
Plane mirror.
Plane mirror. Okay, something like this is coming mean. Can you see myself upside down?
Yes.
Can you see myself upside down?
Yes, sir.
That is the concave mirror's nature. Right. And the third point.
Modern compound microscopes use an electric light source in place of mirror.
Yeah, so in this place, what is there? An electric light source is there. Okay. What is the use of it?
Supplies light to the object.
Supplies light to the object. If it is a mirror, now I have switched on my table lamp. Okay, now the mirror, from the table lamp, light will come and fall on the mirror. Then from there, it will be sent to this place. It will be reflecting and will be directed towards this place. Understood? Clear?
Yes, sir.
Yes. Next one,
Condenser lens.
condenser lens. It is also what kind of lens?
Convex lens.
Convex lens. It is located below the, what is it? Here you can see. Can you see? Above.
Yes.
Condenser below the stage. Does it involve in performing an image, making an image?
No.
No. Then what is the work of it? What is the work of it?
Converges the light beam and focuses.
Converge. Now light is coming like this, mean it will be converging to one point. Then that point will become brighter, correct? Understood? From the mirror, light is coming like this. Because of condenser lens, light is, what is it? Narrowing like this and fall on the specimen. Then what about the specimen's brightness? What about the specimen's brightness? High or low? Tell me.
High.
High. So to get a good brightness to the specimen, we are having this condenser lens. Understood? Understood.
Yes, sir.
Are you clear?
Yes, sir.
Yes. So thereafter,
Yes,
you
sir.
are
Yes.
spoken, Ama. Next it is diaphragm. In the case of diaphragm, this is the diaphragm. Some diaphragm will be there I will later show you that I don't have. There will be a screw. If you turn the screw, it will not have many holes like this. One hole will be there that can open and close. Understood? Here, to get
Yes,
more light, what we do, we turn this, correct? Yes or no?
Yes, sir.
Yes. In other one,
Yes,
this
sir.
one is not there. It will be turned. இப்படி திருப்பினீங்க என்றால் அது வந்து இப்படி கண்ணு மாதிரி இப்படி திறந்து இப்படி மூடும். Understood?
Yes, sir.
So you can open it to get more light, you can close it to get less light. That is one kind of condenser. This is a simply made condenser, I think. Okay. Right. So you can adjust the size of the hole in it, and you can get sufficient amount of light according to your comfortable level and according to the clarity of the image. Understood?
Yes, sir.
Understood? Yes. So rest we will discuss in the coming class on Friday. Okay, we'll meet. Bye.
Jazakallah, sir.
Jazakallah, sir.